It looks like 3I Atlas has been losing an extreme amount of mass, which could mean it's exploded into a dozen smaller pieces.
Well, what we see are 7 jets coming out of these objects, more than 7 actually, after it passed close to the sun on October 29th. And we can see that some of these jets are pointed towards the sun, and they penetrate over 1 million kilometers through the solar wind.
Something extraordinary is unfolding far beyond Earth. An interstellar visitor known as 3I Atlas is emitting a metallic compound never before found in nature, a refined alloy typically produced only through human technology. Observations from major telescopes, including Hubble and the James Webb Space Telescope, reveal a bizarre jet pointed directly toward the sun, a behavior that completely contradicts the physics of normal comets. These discoveries have ignited one of the most intense scientific debates in years. In this video, we'll break down what was detected, why it's so puzzling, and what upcoming observations could reveal. In July 2025, astronomers spotted 3I Atlas entering our solar system on a hyperbolic trajectory, confirming it came from beyond the sun's gravitational reach. It immediately stood out for its immense size, chemical irregularities, and unusual activity patterns. By August, data from the Keck Observatory revealed something unprecedented. Atlas was releasing about 4 grams of nickel per second, yet no iron was detected. In every known comet, nickel and iron appear together in similar proportions. Their separation here was a complete anomaly. Further spectral analysis identified the molecule responsible as nickel tetracarbonyl, a synthetic compound used in aerospace coatings and high-tech metallurgy. On Earth, it is a manufactured material, not a natural one. Detecting it in space was shocking. At the same time, another enigma appeared. Atlas had no standard cometary tail. Instead, it produced a jet of gas directed toward the sun, verified by multiple instruments. The jet contained carbon dioxide, water vapor, trace cyanides, and nickel compounds, but again, no iron. The CO2 to H2O ratio measured roughly 8:1, among the highest ever recorded for an active body. Polarimetric readings showed extreme negative polarization, meaning the object's dust scatters light in a way unlike any comet ever seen. High-resolution images from the Mars Reconnaissance Orbiter's HiRISE camera, captured during its October 2025 flyby, are expected to clarify the jet's structure. However, due to a US government shutdown, the data release has been delayed, leaving scientists eagerly waiting for answers. Together, these chemical, optical, and physical oddities make 3I Atlas one of the most closely studied interstellar objects in history. The detection of nickel tetracarbonyl lies at the heart of the mystery. This compound does not form naturally under any known astrophysical conditions. Its presence forces scientists to rethink how interstellar objects might evolve chemically over immense timescales. The leading view holds that Atlas is natural, just profoundly unusual. One theory proposes that it formed near a CO2 ice line in its home system, where nickel and iron separated differently than they do in ours. Over eons, cosmic radiation might have altered its chemistry, causing nickel compounds to vaporize while iron stayed locked within. In this scenario, solar heating could trigger reactions that create nickel tetracarbonyl without any artificial influence. But not everyone agrees. Harvard astrophysicist Avi Loeb has proposed a bolder explanation: that the refined metal emissions, sunward jet, and precise motion may indicate a technological origin, possibly a technosignature from an artificial object. Then there's the jet itself. Normally, solar radiation pushes gas and dust away from the sun, forming the familiar comet tail. Yet, Atlas ejects material toward the sun, an effect confirmed to be real, not just a trick of perspective. Researchers are exploring whether the composition, grain size, or thermal properties of its dust could reverse this effect. The polarization data suggests the surface may be covered in fine, compact grains, changing how sunlight interacts with the escaping material and altering its dynamics. Whatever the cause, Atlas's behavior is rewriting the models of cometary physics. The implications go far beyond a single object. 3I Atlas offers direct evidence of foreign material that challenges our existing astrochemical models. Finding nickel without iron upends assumptions about how metals distribute during planet formation. It suggests that other star systems might follow completely different chemical rules. This fits a growing pattern. Every interstellar visitor has broken expectations. Oumuamua showed non-gravitational acceleration without a visible tail. Borisov resembled a normal comet, but came from another system. And now, 3I Atlas, massive, metal-emitting, and chemically alien. For astronomers, Atlas reinforces the importance of rapid, multi-wavelength follow-up when new interstellar objects appear. Techniques like spectroscopy, polarimetry, and high-resolution imaging have been essential in decoding its strange emissions. Upcoming images from HiRISE and continued monitoring by Keck, James Webb, and other observatories will refine measurements of nickel output and jet dynamics as Atlas moves farther from the Sun. The soon-to-operate Vera C. Rubin Observatory will vastly increase the rate of interstellar detections, giving scientists a much larger sample to compare against Atlas. If the nickel-to-iron anomaly stands after peer review, it could transform astrochemistry and planetary formation theory. Even if ultimately explained by exotic but natural chemistry, it will still mark one of the most important discoveries about what is possible in interstellar materials. In the end, 3I Atlas has already rewritten the rules. With its sunward jet, metallic emissions, and alien chemistry, it stands apart from anything we've ever seen. Whether it's a rare natural creation or something more mysterious, it's forcing science to expand its imagination and its models for what can exist in deep space. The next round of observations may not just explain Atlas, they may redefine what we believe is possible in the cosmos. And maybe it's nothing. Maybe 3I Atlas is just a rock, a fragment of some long-dead star system, and its movement is just a coincidence. But the numbers don't lie. The data doesn't lie. The object moves with purpose. It pulses with regularity. And that makes us ask, what if this isn't a rock at all? What if it's something much more? We don't know what it is, but we know it's not behaving like anything natural. And that simple truth is enough to change everything. So we watch, we listen, and we wait. Because something out there is moving, and it might be moving on purpose. Comment below, what do you think 3I Atlas really is?